I would like to express my gratitude and thanks to the speaker and also, of course, to Agathe and Mario for the session 3 organization of the symposium of OENOVITI International. This session is a very interesting one because she touched the core, in fact, of the authenticity concerning the wine, and we know how much now it's becoming important in terms of economy, added value, and certification of product of high value. So the speaker, I think that you have seen the program. You have 3 speakers. Excellent one, of course. The first one is Sofia Catarino from the Institut Supérieur d'Agronomie in Portugal. The second one is Tristan Richard from the University of Bordeaux in France. And then we have Marcus Selderich from the Australian Wine Research Institute in Australia. And thank you, Marcus, again, for the effort to stay, as it is very late actually in Australia. We appreciate strongly the effort you are doing for us. And then the session can be organized with the presentation of the different speakers, and we can have the discussion, I believe, at the end. Maybe it should be more interesting with a question like that. All the audience can think to the question and react at the end and exchange with a different speaker. It's okay for you, Enrico?
Oh yes, for sure. Yeah.
You want to also say?
Well, yeah, I would say that authenticity is a crucial problem from the marketing point of view, but also from the origin of the product wine itself. And it is very challenging because authenticity refers to something that should be true. So refers to an identity of the product, but this identity is changing. And so we have to clarify, to testify that something is authentic, but we should before define the identity. So it's not a problem very easy to be solved. So one part is this of the origin, geographical origin of the products, and then the process of making the wine also allows some falsification, some alteration of the process. So it's a very crucial problem because it has economical relevance in the international marketing. So the session of today, this session 3 of OENOVITI International 2021 Symposium is very important. So I'm very interested in listening to the speakers. So yeah, we can start.
Yes, I think we all agree with your words and analysis, Enrico. We can add maybe also two key points, but we will discuss probably later. It's the analysis and the quality of the analysis and the type of analysis, and we need to have a strong analysis methodology. This is a very important point, probably. And the second point is also the data bank and the samples, probably. So two key points that probably are excellent speaker, professor, doctor can explain to all of us. And so I think that we can begin probably with the first speaker, with honor to the lady, Sofia Catarino from Portugal. Thank you, Sofia.
Good afternoon. First of all, I would like to thank the kind invitation to OENOVITI network and this opportunity to share our work on this topic of strong CO isotopic ratios for authentication and wine geographical assessment. Well, it is well known that the wine geographical origin affects a lot its quality and its value in the market. In fact, this information, the information on wine, of the wine origin on the labels of the bottles, provides dignity and trust to the wine in the eyes of the consumers. And this is a very important aspect. And even if the concepts of terroir and the designation of origin are strictly associated to European viticulture and were concepts developed in Europe, it is very interesting to see that nowadays some non-European countries, some countries from the so-called New World, are exploring these concepts and are developing very interesting studies in order to characterize their own terroirs and by this way give added value to their wines. So the assessment of wine authenticity is nowadays of utmost importance in this context of growing market globalization. And in fact, the interest in authenticity topic affects all the food products and in particular wine. And we can see that the number of publications, research studies that have been carried out in the last 25 years increased a lot, with wine taking a relevant place in terms of number of publications. And in particular, the development of analytical tools, of analytical methodologies to positively identify the geographical origin of a certain wine is something of is very challenging and very challenging to the scientific community. Okay, so mislabeling of wine geographical origin is one of the main frauds in terms of wine authenticity. We all know that the cases of relabeling imported wines under prestigious designations of origin are not rare. Other common frauds involves blending the use of non-authorized grapes. And other issues also classified of adulteration as frauds are the classical adulterations, such as sugaring, watering, non-authorized addition of alcohol. Of course, some of these classical practices, that their classification as frauds depends on the country where they are being carried out, the practices are being applied. Also, other practices that in the past were forbidden are nowadays accepted. So it is a dynamic process, I would say. And in order to combat the frauds and to authenticate wines, the use of taggant materials can be very useful. And many producers are exploring them. But I think this strategy can be classified as a virtual strategy. We are talking about virtual fingerprints, as they are not endogenous fingerprints. Also, well, the called light isotopes, and namely the isotopes of oxygen and hydrogen, can be very helpful for the detection of some frauds, namely the classical frauds. They can also provide some information on the growing areas, but in fact, the results are difficult to interpret in terms of variations in the year, in terms of climate change. So these isotopes that currently integrate the European Wine Data Bank are more appropriated to evaluate, to check other type of fruits rather than geographic origin. And the fingerprints, the soil-related fingerprints play an important role here, as they allow to establish a direct relation with the soil of origin, with the geographical origin. And in particular, the stroncio-isotopic ratios can be very useful. Because they allow to establish a strong correlation with the place where the grapevine was grown, where the wine was produced. Well, what does the stroncio-isotopic ratio relationship depend, and why is it a good indicator of geographical origin? Well, the stroncio-87, which is radiogenic, it gradually increases in minerals due to the radioactive decay of rubidium-87. So differences in the relative abundance of this isotope vary with the geological ages and consequently with geographical locations, providing a fingerprint for different rock types. And it is already established, and it was studied in the past, that stroncio-isotopes are taken up by the plant roots with the same isotopic relative abundance in which they occur in the provenance soils. In fact, the stroncio-isotopic ratio is a well-established tracer used since many years for tracing and dating geological materials. Well, this isotopic ratio in soils depends on the rubidium stroncio concentration ratio in the rocks, and also on the age of those rocks. Typically, old rocks such as granite presents higher values of isotopic ratio in comparison with soils and rocks developed on sedimentary formations such as basalts. Okay, so since the pioneer studies carried out in the 90s of the last century by ORN team, a high number of studies were developed in the last decade, involving several countries overworld, namely in Europe, Portugal, Italy, and France, also in Canada, Argentina, Romania, South Africa, Australia, all of them addressing this issue of stroncio-isotopic ratio. The results are they confirm the suitability, the feasibility of this isotopic ratio for authenticity purposes in wines. And I would like to highlight some studies that were carried out in Italy in the last decade that supported, they were used to build maps to support the Lambrusco PDO. So we have already here some practical application of this research. Following, I'm going to present some of our research results on a stroncio-isotopic ratio for wine geographical assessment. Well, it is well known that because of the radioactive decay of rubidium-87 in stroncio-87, it is a very slow process, and this induces very small differences in the isotopic ratio between samples. So this means that we need very precise and accurate methods to do this evaluation if we want to distinguish between samples, because many times the samples present, the wines present very close values, so we need very precise methods. So we developed an analytical method by quadrupole ICP-MES, which allows a precision equal or better than 0.2% expressed in relative standard deviation. This information is published. Well, this analytical procedure includes or obliges to pre-treatment of the sample in order to remove the rubidium from the sample, as the presence of rubidium 87 will interfere in the analysis. So we developed a procedure for that. You can see the information here, which is also published. Within a research project involving or exploring different fingerprints of geographical origin, we have evaluated the strontium-isotopic ratio in the soils of vineyards from 3 different denominations of origin in Portugal. So vineyards where soils were developed on different geological formations. And so the significant differences were observed in terms of isotopic ratio between the different denominations of origin. And as expected, the highest value was found in a vineyard which soil was developed on granitic formations. By the contrary, the lowest values were observed in soils developed on sedimentary formations. So these results confirm that the suitability of this fingerprint for the discrimination of these specific denominations of origin. More recently, the variation of strontium-isotopic ratio in wines of Douro region, taking into account the effect of vineyard location and grapevine variety. This variation was evaluated. The results are already published as well. And we believe that this study represents a development background for building an authentic wine reference for this region. So here you can see a map with the location of the 6 vineyards, or more exactly the 6 wine estates that were considered in this study, all located in the Douro region, which is characterized mainly by schist soils. So a representative sampling of the soils was carried out. Also, here you can see the information on the grapevine varieties that were used for wine production from the previous presented vineyards. Involving both white and red varieties, native and international varieties. These grapes were used to produce monovarietal wines that were later analyzed. And here you can see already the results in terms of strontium-isotopic ratio found in the 22 monovarietal wines. As you can see, the values are very close, ranging from 0.713 to 0.717. So reflecting the proximity of these wines in terms of geological origin. Also, when we did a comparison of the values for between white wines and red wines, no significant difference was observed. Suggesting that the technological process, the technology of vinification did not affect this isotopic ratio. Here we can see some of the results for the soils. When we did the comparison of the isotopic ratio between the different vineyards, vineyard soils, no significant differences were observed. And when we did the comparison between soils and wines, in general terms, when we used all the information for soils and all the information for wines, no significant differences were observed, so indicating that there is no modification of the isotopic ratio from soils to wines. But when we did these analyses using individual data for each vineyard, a significant difference was observed for one of the vineyards. Well, the application of this isotopic ratio is based on the assumption that no modification of the isotopic ratio occurs during the production process, and that the wine reflects exactly the isotopic ratio of the soils. But if we want to assume this and to give as certain, we need to investigate the effect of the technological process. We need to understand the impacts of anthropogenic and technological factors. So for that, we have been dedicated as well to the evaluation of the influences of some of the production technologies, such as the wood aging, as you know, one of the most traditional technological processes in winemaking. So we evaluated the effect of this practice on the wine isotopic ratio, and also the effect of the operation nanofiltration carried out for the alcoholization purposes. So the effect of these two technological processes were evaluated, and the results indicate that no significant effect was observed, suggesting that the application of these technologies in wine production do not preclude the use of strontium isotopic ratio for traceability purposes. So in this slide, you can see the data that we have been collecting, and also other studies that were published. So characterizing vineyards in Portugal, located in different denominations of origin. In purple, you can see the information for soils, and in blue, the information for wine. As expected, there is some heterogeneity, reflecting the heterogeneity of the regions in terms of soils. Higher values are associated to granitic soils, while lowest values associated to sandy and clay soils. When we analyze, looking to these, to the results on a global scale, we can see, and when we compare the information that is available in the literature, we can see that, of course, as expected, there is some overlapping in terms of values between the different countries. But this information, as I told you, concerns the results that are available for each country, not exactly for each region. But of course, there are some questions here, some constraints, because it's in some cases it can be difficult to differentiate at country level or even regional level. And these results suggest that maybe this isotopic ratio, this fingerprint, could be used combined with other markers of geographical origin. Well, almost finishing my presentation, some final considerations. as already said, so soils from different wine regions and countries have been originated from similar geological formations. And this can be a serious constraint in terms of interpreting the data and relating it with the wine provenance. Also, within some wine regions, we can see some heterogeneity in terms of soils and geological materials. And so it seems that in some cases it can be difficult to differentiate both at the country and regional level only through this isotopic ratio, indicated that it should be used together with other discriminating parameters, namely elemental information. And it is crucial to know the soil geochemistry background so a reliable wine relationship can be established. And I'm going to show you results that were published for a different product for natural mineral waters. These results have been published, 10 years ago. And I think this study was very interesting, and so we need to do further studies involving other lithological situations and other world regions in order to develop, if possible, a map like this to confirm the feasibility of stroncio-isotopic fingerprint and to enlarge data. So I think it would be very interesting in the future to achieve this kind of results. Also, other aspects need to be addressed, namely the influence of the vintage here in straight relation with the climate change scenario, and a better understanding of the technological processes. And of course, the aspects, the issues related with the analysis. As I told you before, for samples with very close values, the possibility of discriminating often lies on the 4th or 5th decimal places of the isotopic ratio. So we need very precise analytical methods. This is a very important thing. And also for comparison purposes, the analytical methods should be officially recognized or validated. So it's very important to develop interlaboratorial trials or proficiency tests in order to support comparison. And at last, stroncio-isotopic data can be used to build an authentic wine reference database for an official or wine organization, for a PDO consortium purposes, or to integrate a global database such as the European Wine Data Bank. Thank you all for your attention.
Well, thank you very much, Sophia. So very interesting presentation. And so we can see here how much the analytical methodology can be powerful to help to select and separate the type of sample. So it's a very important issue, and I hope it can be developed, of course, in the future. So maybe we can move on. Enrico, do you want to present the next speaker?
Yes. So the next speaker is Tristan Richard from the University of Bordeaux, and he will present the case of that denomination of origin area, Bordeaux wines authenticity experience, which is another very important example for this subject. Please, Tristan.
Thank you. Do you see my screen? Or...
Yes.
Yes.
Thank you. Thank you. Hello, everyone. I would like to thank the scientific committee to invite us to present our work concerning the authenticity of wine in Bordeaux, the Bordeaux Wine Authenticity Experience. This work was prepared into the Institute of Wine and Wine Sciences in Bordeaux in collaboration with the SCA, the French Wine Fraud Control Laboratory. Just a few words about our lab. Our lab, the Molecule of Biological Interest Laboratory, is part of the Oenology Research Unit into the Institute of Wine and Wine Sciences. We are partner of the National Metabol Hub platform, which is a French platform dedicated to metabolomics. In our lab, we are working on two main topics. The first concerns the chemical analysis of wine and wine products. In these topics, we include the wine authenticity problematic. The second concerns the biological activities of phenolic compounds in terms of plant and human health. As you know, wine fraud is today a major problem in the world. There are many examples of wine fraud that regularly make the headlines, from the most basic cases to very sophisticated examples, such as the case of Rudy Konya one. Just to situate the problem, just through data. At European level, direct losses are estimated to 1 billion of euros by year for wine and spirit, and around 500 million euros just for wine. Indirect losses are estimated to nearly 3 billion of euros per year. Then wine fraud is a very big problem. To respond to this problem, in Bordeaux, we have developed a network dedicated to this topic at the regional level with different partners, public and private partners, universities, laboratories, and of course, syndicates. In our lab, we are working directly on the wine content. We are developing different metabolomic approaches based on NMR and mass spectrometry to analyze wines. Our methods are mainly targeted approaches, but we are also interested to more global and targeted approaches. Today, I will present you our results concerning the NMR. NMR metabolomics, it's a well-known analytical method which conjugate application to foods and food products began in the 2000s. It's used successfully for the control of the authenticity of many foods and food products, such as honey, fruit juice, olive oil, and of course, wine. In our lab, we have developed a simple and rapid method to directly quantify around 50 compounds from a small volume of wines, less than 1 milliliter, with a semi-automatic method carried out from the acquisition of 3 NMR spectra, which take approximately 1 hour, all include the sample preparation to the quantification of all the compounds. As you can see on this NMR spectra, we are able to quantify nearly 50 compounds, including organic acids, citric, lactic, malic, tartaric, and so on, alcohols, glycerol, methanol, ethanol, and so on, phenolic compounds, caffeic and gallic acids, catechin, epicatechin, sugars, and other compounds. And now, I will show you the application of these methods to two main problems. The first, the comparison between 2 bottles of all vintages. The second is the use of the database to analyze the origin of the wine. First, the comparison between 2 bottles. For this, Mouton Rothschild provides us 3 sets of wines of all vintage, set E, A, set B, and set C. and the original bottle from the Chateau Cellar. In collaboration with SCL, we compared the official analysis based on official OIV methods to NMR. Firstly, using NMR, we need less wine and less time. But the question is, have we the same results? In this slide, you can see a principal component analysis of the results obtained by the two methods. On the left, with official methods performed by SCA, and on the right, with NMR. Authentic wines are represented by starred, and suspicious wine are represented by triangles. We obtain the same results using the two methods. We can clearly see that set A corresponds to authentic bottles, while set B and C are fake. Those who are able to compare wines using NMR. But the main problem for the comparison of two bottles is the wine evolution on the bottle, in the bottle. To take this effect into account, we have developed and introduced a method to evaluate wine evolution in bottle over a long period. Using this method, we calculate the number of significant differences between the two samples. We consider that wines with more than 5 significant differences are different. And to illustrate this method, in this heat map, we compare 20 different French wines from two vintages, Bordeaux, Burgundy, and so on. And in the cross comparison, wine in yellow or in red are different, and wine in green are similar. As you can see, only two sets of wine are similar, two Médoc and two wines from the Bourne area. And for me, it's not surprising that wines from the same appellation and the same vintage could be similar. To finish this part, I show you in this slide the comparison of the old Mouton wines using the heat map. In the heat map, the set A appears in green. Then set A, the wine from set A are similar. All the other wines are in yellow, then all other wines are different. Those who have here a basic method to compare wine, to compare bottle of wines. Now, the second problem. In this second case, we want to control the origin of wine using a database. For this, we have built a database which now contains more than 1,000 wine references, mainly, of course, from Bordeaux. And we use it to compare wines. First, I'll show you the comparison between Bordeaux and Burgundy from different vintages. Nearly 150 wines were analyzed by NMR and compared by PCA. In the PCA, Bordeaux wine are in blue, Burgundy wine are in yellow, and we observe a clear discrimination between the two sets of wines. In the cross-validation table, all Bordeaux wines are from Bordeaux, and all Burgundy wines appear from Burgundy. That's nice. But if we take another area, the discrimination is not so straightforward in all cases. In this second example, we compare the same Bordeaux wines to wine from Languedoc. And we observe in the PCA a partial superposition between the two areas. Some Languedoc wines appear to be from Bordeaux. This could be, of course, linked to the diversity of Languedoc in terms of wine, in terms of terroir. Thus, to confirm the ability to use NMR to discriminate origin, we need more sample and to need to have a better database. We need to increase the number of samples in our database. Another result concerns the comparison of Bordeaux wines. In this example, we have compared wine from Médoc and wine from Libourne area from different vintages. Once again, we observe a good discrimination between these wines. In the PCA, Médoc wines are in blue, Libourne wines are in purple, and we are able to discriminate these two Bordeaux areas. Thus, NMR is able to discriminate wine from the same area, wine from Bordeaux. What about the vintage? The vintage is a big problem. The discrimination of vintages is not so easy by NMR. As you can see in this table, which represents the percentage of correct classification after cross-validation of different vintages, the results strongly depend on the vintage. But we can observe a better discrimination when the years between vintage increase. For example, in 2013, the percentage of good discrimination increased with the years between the vintage. When we observe discrimination between vintage, the question is why we observe this increase of discrimination between vintage. And we suppose that discrimination reflects an effect of wine aging in bottle. To confirm this, to confirm the effect, we compare all vintages to young vintages by PCA. All vintages in this PCA are in blue. Young vintages are in yellow, and we observe a clear discrimination between the two sets. For example, young vintages have more catechin, epicatechin, or xylose that are well-known markers of wine aging in bottle. Thus, NMR could discriminate vintages and could give data about the phenomenon of wine aging in bottle. To conclude this part dedicated to wine origin, I show you the comparison between estates of Bordeaux. In this study, we analyzed by NMR the wine of 6 chateaux of Bordeaux from near 20 years. 2 Médoc, 1 Grappe, 3 Libourne. First atoll in the PCA, as you can see, we observe a good discrimination between the 3 areas. The Médoc are in blue, the Libourne in purple, and between them, we observe the Grappe. But we also analyze the data at the level of each chateau. We compare the NMR data of the 2 Médoc on one side and the NMR data of the 3 Libourne on the other side. As you can see in the PCR of the 2 sets, firstly, we observe a clear discrimination between the 2 Médoc for all vintages. For the wine of Libourne, the discrimination is not so obvious when we take all the vintages. But if we only take the most recent vintages after 2000, we also see a very good discrimination between Libourne wines. This is really a remarkable result because this estate in Médoc or in Libourne have the same terroir. Then, to conclude this first part, I hope that these results have convinced you that NMR could provide useful answers to the traceability of wines. Today in our lab, our question is, can we use the NMR to analyze the wine quality? Indeed, NMR is a fast method, simple to implement, robust, using a small quantity of wines, and we can apply it from berries to wine to follow all stages of the winemaking process. thus can NMR also be useful for wine analysis in a more general way? I'm going to present you some preliminary results concerning the analysis of oenological processes by NMR. These results were obtained in collaboration with the Process Engineering Laboratory in Swiss Institute. First example. In this study, we want to know if by NMR we were able to distinguish wines from berries at different stages of maturity. We studied a monovarietal wine made from berries taken at 3 different stages of maturity: 1 week before maturity in green, at maturity in blue, and 1 week after maturity in red. We've performed statistical analysis based on the NMR data, and we used PCA and orthogonal spatial least square discriminant analysis, PSDA, to compare the wines. I show you here some results. As you can see, we are able to discriminate each maturity. And more importantly, we are able to identify the compounds involved in these discriminations. The second example here, it's about enzyme treatments. We studied by NMR the effect of 2 different enzymes on monovarietal wines. The control without enzyme is in green. The enzyme 1 is in blue and the enzyme 2 is in red. Once again, using NMR, we are able to discriminate the 3 modalities, and above all, we identify the compounds at the origin of this discrimination, sugar, of course, sugar, but such as other compounds which can modify the wine properties too. To conclude my presentation, I hope that I convince you that NMR can be useful for wine authenticity and traceability, and could be used to monitor wine quality too. Then, thank you for your attention. I would like to thank all the partners who allowed us to carry out this work on wine authenticity, and in particular Jean-Martin and Soisek La Campagne, which we were working on the monitoring of winemaking using NMR. Thank you.
Thank you, Tristan, for the presentation of the NMR interest and some result and new approaches. So we will see the question at the end after the next speaker, that is Dr. Marcus Elderich from AWRE Australia. And Marcus will talk also about advance in wine authenticity, testing, provenance, notably, and the new world perspective about this point. So Marcus is also the chair of the subcommission of analysis method in the OIV, and it's a very recognized chemist in the field. So Marcus, it's to you. Thank you.
Thank you very much, Pierre-Louis, for those very kind words of introduction. Let me just try to share my screen. Can you see it building up?
Yeah.
Excellent. I'll go back into my presentation. Yes, Pierre-Louis said, I'm in my own work combining science, but also have a background in food control as a chartered food chemist. And through my work with ORV and at AWI, we work for the Australian wine industry. So I see real world examples from real world or from new world producers, and we try to help and devise solutions on a daily basis. I really look forward to travel back to Europe. Unfortunately, not this year, maybe next year, and try to reconnect with all of you, Sophia, Tristan, and the folks and our friends in the audience. Now, to give you a perspective on the Australian wine industry, we are by volume the #6 producer in the world. Almost 2/3 of our product gets exported, and by value, we are #4 producer in the world. That just makes this point to outline that our exports are very important to us. Throughout Australia, from West Australia on the left, around Perth to the east coast around Brisbane, that's about 3,500 kilometers. We have 65 recognized GIs, and they all have diverse geology, which is unique in some regions. Other regions have quite diverse geologies. Now, probably a point of difference to Europe is we can in Australia grow any variety anywhere. So our rules are different from that perspective as well. Wine authenticity, wine fraud, it's not a problem, a new problem at all. It is a problem actually. You already realized that the old Romans realized that wine can be not only a safe product, but also a very attractive product. But at the time back, and currently still, is that the majority of reports about incidents when we have problems with wine and toxicity reported, that's where fake products have been labeled as wine. Products which are wine with not permitted additives or basically completely fake products that resemble somehow wine. So that's one part of the wine authenticity, wine quality game, but also is misrepresentation. That's basically where the label doesn't truly reflect the product in the bottle. There's counterfeiting, that's copying popular and very expensive products, and the specialty of counterfeiting is refill. So it's not a product at all. From an Australian perspective, one of our main concerns, which was driving the research I'm sharing with you soon, are fake products and misrepresentation of non-compliant wines, which are presented in an export market as Australian wine. And we would like to know whether those wines are genuinely from Australia or whether the problems occurred during transit or in the export market. Now, if we look at where government control, industry laboratories come in and where the problems occur, you see fake products. To determine a fake product, we would use NMR and other wine compositional analysis to detect the addition of glycerol, presence of methanol, non-permitted colorants, perhaps sweeteners, other organic compounds. So there's a suite of methods available, and not at point of sale, but certainly in the analytical lab, it's quite easy to detect a fake product. Now, the middle section is where most government control laboratories focus their efforts. So that's where a combination of audit trails, chemical analysis, and comparison to databases. This is where misrepresentation gets detected. For instance, an example is a bottle of wine from Australia would be labeled as Barossa Valley Shiraz, and then the question is, have those grapes been grown in the Barossa Valley? And indeed, are those grapes, were they Shiraz grapes? So there's a combination of databases, analytical chemistry coming into play. Specialty we have in Australia is we also have a wine label directory for exported wines, which helps us to basically also detect IP infringements or potential IP infringements, potentially even before the product gets exported. So most of my presentation today will look at trace metals and in particularly isotope ratio measurements, similar to what we have heard from Sophia in her excellent presentation earlier tonight. Now, on the right-hand side, the blue column, true to type testing, which is from our perspective equally important. So here's the question, can we trust the wine in the bottle or the wine in the tank we purchased? So this is basically disputes, this is uncertainty in the trade. If you are a winemaker and you just purchased grapes labeled as Chardonnay, from time to time we would like to verify if you indeed have purchased Chardonnay and not other wine varietals. If you buy, let's say, Pinot Noir wine from a contract producers, of course, as a buyer would like to verify that you have purchased indeed Pinot Noir. Is this a wine you made? Counterfeiting, for instance, comes in, like the comparison of products, where basically one could potentially be a copy of a popular product in the market. And refills, that seems to happen in the on-premise, in the gastronomy trade from time to time, where existing and accurately labeled bottles are refilled with some other products that's conveniently at hand. Now, counterfeiting and refill, just to build on Tristan's excellent presentation, they are fairly easily detected in a laboratory, but not at a point of sale or in a restaurant. It simply is a true to type test, as we call it, where you compare the suspect product with a sample of the genuine product or reference data in a database. And there's a variety of methods available: spectral methods, NMR spectroscopy, HPLC mass spectrometry. Well, that's fairly easy in the lab. Now, before I go into the isotope ratio measurement, I thought it's important to look at our regulatory framework so that you better understand where we come from. The two major aspects I'm going to discuss briefly today are our label integrity program. That's about the representation, and then the export controls, which are now managed in a digital format through Wine Australia's licensing and approval system. Now, the label integrity program, and that applies to wine made in Australia, sold in Australia. Important point is label claims are not mandatory. You can sell your product as wine or Australian wine in Australia. However, as soon as you put on the label reference to a vintage, a year of production, here 2011, a region, Barossa Valley or Shiraz, as soon as a label claim is made and perfect audit trail from the finished product back to the grape purchase must exist to substantiate any claim. And Wine Australia is a government agency tasked with effectively informing and conducting those audit trails. To give you an idea, we are auditing approximately 75% of wine produced by volume every year in Australia. Now, from an industry perspective, it's important to note that the label integrity program does not prescribe how records are kept. You can use your own paper records, you can use digital databases, but the information that must be recorded is prescribed. So for Australian wine sold in Australia, label claims as to region and vintage, the first point of touch and to monitor what's happening really are very precise audit trails involving the producers. For variety claims, we have of course the audit trails, but we also have analytical techniques available. We use protein profiles for particularly white juice and white wine samples, because we have noticed some time ago that grape varieties have certain proteins which have very distinct molecular masses, and this molecular mass information can be read out with electrospray mass spectrometry and gives you variety specific mass spectra. Of course, in red wine, anthocyanins are very handy. And we also reasonably gained access to NMR and databases such as food screener databases. Now, just summarizing wine authenticity and misrepresentation. What are the consequences of misrepresentations? That's wine made in Australia, sold in Australia. Honestly, most problems get identified by industry and audit trials prior to the wine release to a domestic market. If not, we have robust enforcement in Australia, but I couldn't find an accurate record for wine, anything specific. So here's an example of what we mean by robust enforcement. This is a case from a supermarket which sold baked today and freshly baked in-store labeled bread inside the supermarket. And they were fined $2.5 million for basically making false or misleading representations, simply because that the bread came in as prepared, frozen or cooled storage dough, and only was effectively warmed up in the store. Just to make the point, the enforcement in Australia is quite active, and it's a very costly mistake to basically get label representations wrong. How about Australian wine exports? For export process of Australian wine, the person exporting the wine needs a license, the product needs to be approved, and the shipment needs to be approved as well. And the government agency, Wine Australia, has the rights and the powers to effectively refuse approval where they believe that the description and presentation of a product is breaching the Act, Australian law, and importantly also the law of other countries. And there are a couple of more recent examples where very publicly either licenses of exporters were cancelled or product shipments were stopped because there were doubts about the claims made or the representation of the product. Now, summary, it seems, we believe actually, that we have very robust systems. And I guess I try to get the message across. As much as we love our chemistry and as important it is, it all starts with accurate records and being able to verify those claims with very good audit trails. But then the targeted chemical analysis is also essential. So what's the problem here? The question for us really was, can we determine the provenance of an unknown wine samples sold as Australian wine outside Australia? And to give you an idea where problem we are talking about, the next one is a very recent publication which outlines the challenge at hand. Was published this month actually in Food Additives and Contaminants. It's an excellent study where German food control worked together with their Chinese colleagues, and they analyzed 50 European commercial wine samples. They were labeled as European wine in the Chinese market. Obviously, based on labeling, 10 samples were classified as suspicious, and based on the analytical chemistry results, 11 samples were based as suspicious. Please note that analytical chemistry and labeling not always go hand in hand, but the result was there were 11 wine samples which seemed not to comply with regulations because they had sugar added, water added, or glycerol added. Now the point is, that's where our work comes in. Those wine samples were labeled as European, French, Italian, German, Spanish wines. And obviously what all authorities and producers are now very keen to work out whether those samples really originated from the European producers or where the problem happened. And I guess the reason I mentioned this example is it's a very good example where the authorities, the relevant authorities in both the producing country and in the receiving country work together. And this is where our work really comes in. Now, the question really is if we receive an Australian wine sample from an overseas, from an export market, can we use a mass spectrometry to determine the provenance of such an unknown commercial wine sample? We started building on the good work from Sophia Katarina and our other European colleagues using strontium isotope ratio mass spectrometry and trace element analysis, and had some success. And then more recently added 2 more parameters to it, boron 11 isotope ratio mass spectrometry and also oxygen 18 in the water that's in a bottle of wine. And on the right-hand side, you see a plot where we have depicted Australian commercial wines in pale blue and wines from other producing countries from around the world. And you see there's a relatively good separation just based on those 3 isotope ratios and based on country of origin. We also looked at a couple of other parameters, lithium and lead isotopes specifically. Now I told you we quite like boron 11 isotope ratio. So one of the questions we had to look at, does the type or origin of a bottle glass affect boron isotope ratios? In other words, do we have in Australia specific boron levels in wine simply because we only have 1 or 2 glass producers in Australia, which then make glass with a very specific boron 11 isotope ratio? And the answer is no. Here we tested bottles of different color. We tested plastic bottles, so that HDPE bottles, and we tested bottles made in different country of origin, filled all of those bottles with a single product, and then looked at a number of products and looked at the boron 11 data, and they were relatively consistent. So the answer is the bottles, the packaging is not a source of variation. We can really link back differences in boron 11 to the country of origin. How about winemaking? Now, the first starting point was to compare red wine versus white wine, because of course in red wine making we have a lot of skin extraction. In white wines, the skins are typically separated from the grapes early in the winemaking process. So on the plot in the right side, which combines a number of 5 isotope ratio measurements, you see in red dots the red wines and in green the white wines. And initially it appeared to us that the white wines are for whatever reason separate from the red wines, and we were wondering whether we were looking at variety effects or winemaking effects. Now, on closer inspection, we realized that really the lead concentrations in those white wines were way higher. Here you see a histogram, a distribution plots in red wines, and going back, you see the lead concentration on the left side, basically driving the separation of the white wines to the left. So why is lead in commercial white wine typically higher compared to red wine? And it comes back to bentonite fining, which is a common practice in white wine, but not typically used in red wine making. Now, to test this idea, we used 3 different white wines and fined them with 6 different bentonites. 3 were sodium bentonites and 3 were calcium bentonites. And what you can see in the plot on the right-hand side, obviously our untreated white wines with the small green dots, so 3 wines, and the small diameter shows you the small concentration around 1.5 microgram per liter. The middle section, 6 white wines fined with calcium, and you see that actually depending on the bentonite, you see differences in the increase of lead. So clearly lead is a function of the bentonite use, but you also see differences to the lead isotope ratios. And on the left-hand side, you see that the sodium bentonites added quite a fair bit of lead to the product and changed the isotope ratios as well. So the summary of this study was that bentonites leach lead at very small concentrations in product, which influences the isotope signature. In short, lead isotope ratios can be affected by the use of bentonite and therefore have limited utility as a determinant of geographical provenance for wines. Obviously, an individual producer who understands the bentonites very well can create, if they wish to do so, a distinctive lead isotope signature in the wines, but that's just a side aspect. The same study also showed us that the isotope ratios of boron, strontium, and lithium were not affected by bentonite in any material way. Finally, vintage effect. So the question here was, does vintage, like weather conditions, changing grape growing conditions, affect the isotope ratios in wine? We didn't see, similar to Sophia, we didn't see an effect on strontium isotope ratios, but we actually saw in some wines an effect on oxygen 18 in water in wine. Here, the green circles outline a number of samples in Semillon wine from region Hunter Valley, where in 2008 and in 2012, the delta oxygen 18 values were significantly lower what you see in all the other samples. So I guess for those of you who are interested in oxygen 18 measurement in PLOE, that's a very important topic at the ORV as well. I think we have to be acutely aware that vintage conditions, whether vineyards are having natural rainfall or are irrigated, will have a significant effect on the measurements being undertaken there. Summarizing my presentation here is, I guess, from our experience, it's really important to build databases, and that the databases involve commercial wines used using common and permitted commercial practices. In other words, where apparent irregularities, outliers are detected by comparison of analytical data to databases, we really need to be mindful that what goes in a database defines a normal reference wine. And there always can be situations where outliers still relate to normal and permitted practices. It's just that the database basically is constructed in a way that it's not comprehensive enough. Similar to what Sophia has shown, we believe that there are inputs in vineyards, such as foliar sprays, for instance, as nutrient sprays, can influence trace element composition and potentially isotope ratios, such as boron ratios. We believe it's very important to consider seasonal conditions during grape growing. For example, as I said earlier, rainfall, irrigation water used. The type of irrigation water used, is surface water used for irrigation, is it water coming from other sources? And obviously dry grown vineyards will have a very different isotope pattern as well. And we also need to consider the impact of established and novel enological practices on isotopes and elements in wine. For example, dealcoholization or electrodialysis as subtractive methods will affect isotope ratios, whether it's oxygen 18 ratios or other isotope ratios. And I don't think we have tested how emerging enological processes such as polyaspartate additions can add or subtract or mask some of our elemental markers. Now, this brings me to an end. I really would like to acknowledge the work my colleagues have done. A project started with Dr. Martin Day, and Dr. Eric Wilkes is the lead in this field. I'd like to acknowledge the support from Rachel Triggs and Steve Guy from Wine Australia. Many discussions we had, access to samples. CSRO Land and Water supported the work through access to various isotope ratio mass spec techniques. Our colleagues at Charles Sturt University helped with the multivariate statistics, and the Australian wine industry for support and also provision of samples. And last but not least, our funders from Wine Australia and the industry. Thanks PLOE and the committee for having me today, and I look forward to hopefully meet you all in the very near future and to have a chat, a laugh, and discuss what's happening in our lives and in our science with all of you in person.
Thank you very much, Marcus. Very nice also presentation. I just want to congratulate you, Marcus, but also Tristan and Sophia. I think that really we had an excellent presentation that do a real point on authenticity and the different approaches, what are the gaps and what we can attend at the moment. So it's very important. So I think the audience can begin to ask a question. I should begin, Enrico. I have just maybe two questions, just two questions. Okay. Each one of you can give your point. First one is, in your opinion, how much analytical parameters are needed to differentiate sample? That's differentiate for certification, of course, samples. And the second point is, what can be an acceptable variation coefficient proportion also? This is also a second point. So it's maybe more on analytical point, but I think it's of course of importance. And I would like to have the viewpoint of each one of you, because you are using different type of methodology, different type of analytical material. So I think there is a real importance there. So thanks to all of you to give your view on this.
I can start
Yes.
with your second question, Pierre-Louis. The variation, I cannot quantify it, but I believe that what I would call biological variation or process-related variation is way more important than analytical variation.
Okay. Okay.
Yes, I agree with Marcus. The main problem is the biological variation, because today you have very sensitive and very precise system to quantify compounds. But winemaking, it's a big problem, because we have a different process, and also we have different origin, and we have, for example, for analytical parameters, we have the wine evolution that impact a lot all the data. Then it's quite complicated in terms of biological variation.
Okay.
Well, I would add a comment also on the uncertainty of the analytical methods. So we need very accurate methods, and giving us measurements very precise. I'm thinking in terms of the strontium-isotopic ratio. This is a critical issue. And under their point of view, of course, we need to choose the analytical techniques that can give us more precise results. And of course, the biological variability, as my colleagues told us. And regarding the first question, how many parameters, if I understood well, it is the question, how many parameters do we need to be able to state without doubt that a certain sample comes from a certain place? Well, this is a difficult question. Of course, ideally, we should be able to do that identification using only a single parameter, but it seems that that will be very difficult. So we need to combine different parameters. And that's why I think, well, maybe the enlargement of the European wine data bank integrating other parameters, not only the light isotopes, but strontium isotopes, some mineral elements, not multi-elemental composition, but some elements that allow to establish a straight relation with the soil of origin. This enrichment of the wine data bank could be a good solution. And in fact, as far as I know, each year, each European country, each partner sends information on authentic samples to enrich, to feed the wine data bank with the information for light isotopes. So maybe this information could be enlarged to other analytical parameters. But as much parameter, of course, we can predict with higher confidence if we use information from different parameters. As much parameters as we use, we can increase that certainty. But there are other practical constraints, of course, to be into account.
Yeah, and in my experience, the real problem of wine food, when we compare wine, is very complex, and more information we have, better we are sure that we stay, because in some case, it's very easy to compare wines, but in some cases it's very complicated, and more information we have, better is done. Better is the expertise that we have.
So can we say that if we try to combine different databases from for the same type of sample, of course, the same sample, but with different analytical methodology, give more robust the pool, in fact, and the probability to be right?
Yeah, I agree, Pierre-Louis. The more comprehensive a database is, the more diverse the sample you have in there, the more likely is that you avoid false positive or false negative results. But that becomes a very comprehensive exercise and a very expensive exercise, and I'm afraid we are always behind reality. The other way of approaching it would be that you do true to type tests where you have a reference sample effectively, where you had a spectrum of wines in a database, and if there's a suspect case that you compare those samples. That's where, for instance, NMR I think is an excellent technology. Ideally you would like to have non-invasive technologies, but I think they are certainly lacking the sensitivity to do isotope traces inside a bottle without opening the bottle. So I think we have probably to rethink the approach of using databases as the main point of reference, where the databases, they will never be comprehensive unless you capture wines directly from the producer in a database, as we do with labels in Australia. Can I ask Tristan a question, please?
Yes.
Yes, of course.
Obviously, with NMR, you pick up the organic composition of a wine sample, which is very distinctive and works in some instances and not so well in other instances, as you have shown. We in Australia have a trend where, I believe you have the same in Europe, where an increasing number of wines are made by spontaneous fermentation or wild fermentation or uninoculated fermentation. And in our experience, the profile of organic compounds, fermentation products in a wine is changing substantially as a function of the yeast culture used, whether it's pure yeast, and it becomes almost unpredictable if you have spontaneous fermentations and wine made by spontaneous fermentations. How are you planning to address this challenge going forward?
Yeah, we're covering today. Our concern is to know how NMR could follow the winemaking process. And for example, we try different yeasts to see if we are able to discriminate yeast. And we observe that we're able to discriminate yeast. It's very interesting because we can put NMR to a service of oenology, but the question is after, are we able to follow the authenticity? Two different problems. But with NMR, we have very nice results for we have trying to monitor finding agents, and we observe differences using different finding agents in the wine. Then it's very, very interesting in terms of science. In terms of authenticity, it's more complicated because that signifies that winemaking practice influence a lot about data concerning authenticity. But,
do you believe that 60-80 megahertz benchtop NMRs are good enough for the job to do in-field control in a winery, because they have the potential to replace many other more complicated methods, or is the resolution simply not there and the sensitivity?
The sensitivity, the NMR field, it's not the main parameters. I think with the field spectrometer, you can have more or less the same results, because we observe the main compounds, and then I think it's not necessary to have a high field spectrometer to make these studies. I think.
Enrico?
Yes, I would like to to add an observation. Actually, the analytical power is very, very high and very precise. But the biological origin of this product makes a huge variability from the beginning. So another way to address the problem or to combine could be traceability, that now with some electronic systems, the QR code and so on, I don't know if that could help to precise more, to get the whole process more sure, or what do you think about just an observation?
Yeah, we absolutely agree with you, Enrico, because embedded system in the labeling or the bottle or elsewhere obviously would complement classical chemical analysis and would also allow a verification of a sample at the point of sale.
Yeah.
So ideally, you would like to combine the two aspects, having a mass spectrum and NMR spectrum, a UV-Vis spectrum of said wine, linked perhaps with some blockchain mechanism to some other mode of identification, which is not linked to the composition. And there are commercial solutions available for that purpose.
Yeah.
But none of the commercial solutions will tell you where the wine has been made. It just tells you who has bottled it.
We have some question also from the audience. At least there is 4 or 5. First one is from Turgut, our colleague Turgut Kabaroglu from Turkey. He's asking if DNA barcodes can be used in wine industry.
In terms of analysis of wine, or in terms of label of the bottle?
Probably both, but in terms of authenticity, is there some things to do, or? Yes.
I believe there are companies are not developing or already providing DNA which can print it as effectively a barcode, an invisible barcode on a label or on a bottle that's outside. DNA inside a wine, there's at least one Italian research group which has quite a lot of experience with isolating DNA out of wine and sequencing it. I'm just not sure personally about stability of DNA in wine. And as it falls apart, it becomes shorter how much valuable information is still retained or gets lost during the aging process. And I would expect that wine, particularly wines that gets fine to remove protein, that also DNA can get lost through standard permitted production processes. But yes, the answer is both. DNA barcodes can be used. The labeling application is close, already available. The DNA analysis in wine is at the development stage.
Okay.
I think a Germany company developed a solution using DNA, I think in Germany, and they used DNA to monitor the wine authenticity. But I don't know if they have a product on the market or not.
The point is to have enough DNA to do a correct analysis. And that's also a key point there, because during a lot of long time ago, everybody thinks that the DNA will be the solution for authentication of the wine, but finally it looks more difficult, especially after all the process and the enological practice. We lose a lot of DNA. That's also one of the trouble probably here. So probably there is a lot to do on this way. Second question, it's from Jochen Usner saying, many thanks for the fantastic insights the speaker have shared. As we have seen, the danger to authenticity is a very real one, which is underlined by other recent cases in both basic as well as investment grade wines. Many of the tools proposed require lab analysis out. What are the options at point of sale to identify fake wine or solutions that work at greater scale? It's a good question.
Commercial solutions are available using a number of different technologies. It's typically a non-destructive testing, whether it's near-field chips embedded in packaging into seals, laser etching of bottles, DNA printed somewhere, nanodots, name it, and you can get it. It still requires technology at the point of sale, though.
Yeah.
But yes, Jochen, you're absolutely right. That would be desirable solution. That you buy a bottle of wine and you can verify it at the point of sale, and perhaps the winemaker talks to you over a computer screen while you are trying to pay for that product.
Yeah. Okay. The third one is from Antonio Graca. Antonio is telling us, our friend Antonio is telling, these methodologies require massive amount of data to be processed with many iteration and simulation, which become impractical to apply in a routine control manner. Could this be a field where algorithms could bring a strong boost of feasibility? Are you aware of any research on this direction?
Difficult one, Tristan.
Yeah, I know, because if the authenticity do not need a lot of techniques, I think it's more a lot of doors that you can open when you have a problem. I think on an only database that containing all the parameters, it's impossible. But different doors that you can open to answer of a precise question is the way that we can follow.
Antonio Graca precise, hein? I mean artificial intelligence also. Hein? So,
yeah.
Artificial intelligence and algorithms, in fact, it's what it means.
I can comment, look, I think the constraint are you cannot have cheap, fast, and sensitive methods. So the constraint is a method, not the data processing. Tristan, help me if I get it wrong, but in my lab, if we have to analyze a wine sample by NMR, you adjust the pH. That's automated. That takes minutes. The spectrum collection sets minutes, like under 10 for 70 or so parameters. Then you upload it to a database from a service provider and you have your result back within minutes. So I think companies have invested in artificial intelligence, or what I call process bioinformatics, to get the information out of the mass specs and NMRs reasonably fast. I think the real problem is that technology is too expensive for the winery or for a supermarket or a wine store. So that's where you probably need to look at other solutions.
Okay.
And the other comment I would make, artificial intelligence is only as good as the input data you have available, which need to come from some physical measurement technology or packaging approach.
Yes, I think if you want to use, sorry,
just to add a comment to what Marcus said. Also, under my point of view, not all the samples, not all the wines that are in the market, not all the bottles need to be checked. So we just need to have technology to test suspicious wines. So this reduces a lot the number of samples to be analyzed. The objective is not to submit all the wines to the test. So somehow how it happens nowadays with the investigation of the classical frauds, adulteration. So only the samples that are under suspicion, they need to be tested. And in the last years, there were some developments in terms of technology For example, for strontium isotopic ratio, we have different possibilities to do this analysis. The method that we developed requires a pre-treatment of the sample in order to eliminate interference, but there are other techniques that allow a faster determination. So there are also some developments that result in a faster analysis and faster results.
Okay. We have two other questions. One is from Ivan Smajlovic. He's asking about, are there some comparison results on isotopic profile for wine sample which are previously dealcoholized using, for example, special practice like reverse osmosis, electrodialysis? Are these values consistent or they change? And how it will influence future development of European wine database?
Well, maybe I can start. Regarding the strontium isotopic ratio, we did this evaluation with a limit number of samples, of course, but we did this evaluation in what concerns nanofiltration, which is a separative process, and that's why we choose this to study this technology. And we did not observe significant differences between the control samples and the samples treated by nanofiltration. And I mean nanofiltration carried out for the alcoholization purposes. We are able to analyze till the third decimal place of the isotopic ratio with our equipment. And so we, at that far, we didn't see any significant difference. I know that there are some studies, if I'm not in error, for the light isotopes, but I'm not sure about the results. But if I'm not in error, there are some published studies on this as well.
Okay. Do you want to comment also, or is it okay for the three speakers on this point?
I think I can comment briefly, fully support what Sophia has said, but I believe this also outlines how important it is to build your databases around commercial wines or wines made with permitted practices, and not only rely on databases built on experimental wines, which have a very limited set of winemaking methods being used. Okay. So basically make sure that the wines going to be used for the database building are diverse as possible.
Okay. We have after that two last points. One is concerning addition of nanoparticles to the wine. Is it a process that can help maybe to identify better the wine? So I am scared a little bit with nanoparticles as a food safety examiner, you know, because we don't know about the toxicity. I can answer this point, and to put nanoparticles in the wine will require healthy and safety and toxicology probably data. So I am not sure that it's a good way to manage the thing, but I don't know what you think, the colleague. Did you agree on this point, or do you think there is maybe some specificity?
Well, from my point of view, it would be preferable to trace a compound or a chemical species that is already in the wine. But of course, I understand that there is a practical concern. Well, but I think you are right. I share your concerns regarding the introduction of nanoparticles in the wine for that purpose.
Yeah, I'm the same. I share the concern of adding something else to wine, unless it's already there or permitted. The other lens we could apply is would addition of nanoparticles or some other compounds or macromolecules such as DNA facilitates the detection? Would they give us, as Jochen has asked, with a unique opportunity to deploy a low-cost, low-tech assay for the point of sale? And I haven't come across such an opportunity.
Okay.
So I think not everything what is possible, if we forget about the safety aspects, will be an improvement unless you have technologies that can pick that up as well.
Okay. A last question by Liliana Martinez. Liliana from Argentina is asking, is there some authenticity analysis or methodology recommended by OIV? Are the same presented here in the symposium or different?
Well, the OIV describes methods for the determination of light isotopes.
Yep. And we have recently added NMR spectroscopy, but at this stage only for the quantification of a small number of the compounds which Tristan has in his panel. Obviously, the OIV is concerned about the isotope measurement, but traditionally that has been mainly deuterium and oxygen-18 in fermentation ethanol as a way of detecting chaptalization.
Yeah, more generally, all the methods of OIV, official method of OIV could be used in the purpose of authenticity. For example, the classification of anthocyanins. If you suppose a use of another variety, the classification of acids, there is all the methods are useful, depending of the problem.
Okay, thank you. Enrico, do you have a question?
No, thank you. It's okay for me.
It's okay for you? Okay. I think that there is no other question from the audience, but I think that we did a good turn. Yes. Good point. Sure. Huh? Excellent session. So really, I would like to congratulate all of you and of course the three speakers. I want to thank also Agathe, Marion, Enrico, that was co-chairing the session with me. I think really that we should focus in the network to develop a project of interest all together about it, because really there is so many things to do that we need to work at an international level there. How we say, hand in the hand, or la mano en la mano. I think it's a very important issue there if we want to advance. And last point, I just want to tell everybody that tomorrow is the last session of the symposium. In fact, tomorrow morning, I think Agathe has sent to you inside the conversation box the program. The session will begin tomorrow morning at 10 o'clock. It's concerning winemaking and wine growing innovation and novelties. And we will have several speakers from different places in China that will present some digital aspect, but also future in the industry, innovation also at the cultivar, and the vine cultivar, or grape diversity. So I think it's something that should be probably also interesting, completing the already 3 sessions that we had during the 2 days, the 2 past days. I would like also to thank the audience because we had around, I think, 80 or 19 people that were following this session. That is very nice. And of course, the interest of the executive committee of the network that is trying to give you the most interest in terms of topics in general, or selection of the speaker. I think that we had probably 3 best one that we can have, really specialist of the question, and it's very interesting. So thank you very much to all. I think that we should stop here for 2 days, and we can say see you tomorrow for the one who will attend the number 4 session. Thanks to all, and bye-bye.
Thank you all.
Thanks. Bye.
Bye bye all.
Bye.
Bye all.